All right, the first part of this is embarrassingly easy, elementary, but I'm going to do it anyway. It's in my notes, so I'm going to put it in here. So let's talk about some operations, math operations. We just got to make sure that we're good on the vocabulary, so when we talk about these words, everybody knows what I'm talking about. All right, so math has its own vocabulary. So let's do addition first. So I'll just put add for addition. Addition, this is A plus B. So if you have a number plus another number, that's addition. Now, what I really want us to understand on this little section right here is what do we call the answer to an addition problem? It's called the sum, right? It's the sum. So if I say the sum of two numbers, that means what are you going to do with those two numbers? Going to add them up, okay? That's what we're looking at right now. Very simple, basic. So what about subtraction? That looks like A minus B. What do we call the answer to a subtraction problem? The difference. Very good. So it sounds like you've been taught this before, and you should have. I mean, this is stuff that you learn when you're a little kid, not for the first time. All right, and then let's do multiplication, multiplication. Now you can do multiplication a bunch of ways. When you get into algebra, they first show you multiplication with a little dot. When you're a little kid, what do they use for when you're a little kid for multiplication? The X, right? But when you get into algebra, you rarely ever see that. Or you could go A times B in parentheses. You could have one of them in parentheses and one not. That's another way to show multiplication. Or you could just have the two letters right next to each other. If there's no dot or there's nothing in between, what does that automatically mean? It means multiplication. Okay? What's the answer to a multiplication problem called? Product. Very good. Write that down. Okay, what's the fourth operation we're going to talk about? Division. All right, so now, again, when you're a little kid, you did that X for multiplication, and then you did this thing. Right? We are rarely going to use that. There's going to be a time when we do some division, and it's going to be long division. Remember doing long division? Right? But we're going to do it with letters and exponents. All right? We're going to do long division with that. And you might see this symbol for that. Okay? They'll say, take this divided by this. But most of the time in algebra, I'll wait for you. Most of the time in algebra, you would see a division problem written as a fraction. That means division right there. It's A divided by B. It's the top divided by the bottom. Everybody understand that? All right, so that's in algebra we usually see that. What's the answer? What do we call the answer to a division problem? The quotient. Very good. So you've definitely been taught those things, which is good. I'm glad. So here's an example with the stuff that we just taught. I'll do it right here so you can see these things. They're going to give you a phrase, and you have to write down the algebraic expression. When I say an algebraic expression, for instance, like if I said 3x plus 2, that's an algebraic expression. All right, so it's not an equation. Why is it not an equation? There's no equal sign, right? There's no equal sign. So this would be considered an algebraic equation. When you have letters and numbers, things are being multiplied, added, subtracted, divided. Okay, that's an algebraic expression. Algebraic meaning it's got numbers and letters, right? The letters stand for numbers. They represent numbers. So that's what we're going to do. We are going to, they're going to give you some words, and you're going to write down the expression, the algebraic expression. So here's the words. It's the sum. First one's super easy. The sum of 2 and 7. All right? So what you have to do is just write down that expression. First of all, you got to know what sum means. What does that mean? What are you doing to those two numbers? You're adding. So the only thing you do is just go 2 plus 7. Now you don't have to say equals 9, all right, because this doesn't say equals 9, does it? It just stops right there. It just says the sum of 2 and 7. So that's all you need to write. You don't actually have to solve it. Okay? Pretty easy, isn't it? Let's do another one. It's just as easy. It says the product of 3 and 5? They're not all going to be this easy. Some of them on the homeworks, my guess is, I haven't really looked at it, I don't have it in front of me, but my guess is they're not going to be all this easy, but it's going to be the same idea though. So first of all, you got to know what product means. What does that mean? It's the answer to a what? Multiplication. That's right. So what do I do with that 3 and that 5? I multiply them together. Now you don't have to give me an answer. So you could write it a bunch of ways. You could write 3 then a dot 5. You could write 3 in parentheses, both of them in parentheses. You could write just one of them in parentheses. That's usually the very common way to show 3 times 5. I mean, technically, I guess you could put the x, but we don't really do that little x thing in algebra very much at all. All right, so we're going to kind of try to stay away from that. But these are 3 good ways to write the product of 3 and 5. Could you just write, like, remember I said you could just put the 2 things next to each other? Could I just go 3, 5? Does that mean 3 times 5? No, that means what? 35, right. So that does not mean 3 times 5. So don't write it like that. Okay, but you could put it in parentheses. Now that does mean that you're multiplying them together. All right, enough of that. That was pretty easy. Now there's also an order that you have to do those things. And they call it the order of operations. Order. And you've seen this a bunch before. Order of operations. Do you remember this thing? PEMDAS. It seems funny because I don't know how many years, but when I was first teaching, nobody ever said PEMDAS. We always said, what are these letters? What's a little device, a little mnemonic device that we learn to learn PEMDAS? Please, do you remember that? My dear Aunt Sally, right? Okay, so you can, and that's what we used to say all the time. But it seemed like in the last several years, people say PEMDAS all the time, and I never remember people saying that in the past. Isn't that weird? I don't know how it caught on. But anyway, everybody says PEMDAS. What does that mean? What is the P represent? I'm not going to write them down. You can if you want. Parentheses, then what? Exponents, multiplication, division, addition, subtraction. Okay. Now the thing is, the multiplication and division, if you have multiplication and division in the same problem, you kind of do those at the same time. All right. You don't necessarily have to do multiplication first before division. It could go interchangeably. Same thing with addition and subtraction. You kind of do those at the same time. All right. Maybe we'll have an example. Maybe we won't on what I'm talking about. So let's do a quick example. If you look in the book, it's example 8. They got 3 examples here. They're all pretty basic and easy. All right, so what if I ask you to evaluate this expression? All right, sometimes they'll say simplify, sometimes they'll say evaluate, but what it means is come up with an answer. Give me an answer for this. All right. So a lot of people, if you didn't learn the order of operations, if you did not learn PEMDAS, then a lot of people would just go, oh, 3 plus 4 is 7, 7 times 5 is 35. You ever see on social media, now I look at Facebook because I'm old and I don't care about all the other social medias. It's the only one that I really look at. I don't really look at, my wife watches TikTok all the time. She's so doom scrolling, is that what they call it? Boom, 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 just scrolling, scrolling, scrolling. Once in a while, she'll, what do you? Oh, is that what you do? Okay. I have, was it TikTok? I got it on my phone, and I rarely ever look at it just because it's nonsense. But sometimes I could see where it'd be entertaining. Anyway, but you might see some things, especially on Facebook, where they just have a meme, right? Where it's not a video, and they'll say, what'd you get for this answer? You ever see those? Like on Instagram, you probably see that, right? If you're on Facebook, you'll see those. And they have like a longer version. Then you get like thousands of people commenting, oh, I got this for an answer. And then people say, no, it's this. And they're like, well, I'm a math teacher, and this is the answer. And then you get like 4 or 5 different answers to a problem. Right here, you probably only get 2 possible answers. You'd probably go 3 plus 4 is 7 times 5 is 35. Some people might say it's 35. What would you say it is? 23, right? And I don't think there's too many other options with something that simple. Why is it 23? Because we do multiplication before we do what? Addition. This is the order that we do things in. So we have to do this thing first, and then you can add it to the 3. So I would go 3 plus 20, and that's 23. So if you have a question like this, I want you to show your work. All right? You've had me before. You know I kind of a pain in the butt about showing your work. Don't just, if this was like number 1 on your homework, don't just put 23 and then go on to number 2. Everybody understand that? All right, so if I just see 1, 2, 3, 4, 5, whatever it is, and all I see are just a whole bunch of answers, and you could have shown some work for it, I'm not going to give you full credit. I'll take points off for that. And I'll say, what? Anybody see this on their homework? Show work. All right? I might even put an exclamation point and underline it if I get a little ticked off. All right? So make sure you show your work. Write the problem down. Okay? Don't just start with this. This is what I would do. This exact thing right there. If that was on my homework, that's how I would write it down. Okay? I'd write the problem, write number 1 in front of it or whatever number it is, and then write the problem out, show all your steps, show your answer. Then what should you always do with your answer? You should always circle it so that I can see what it is. Now, I don't grade your homework on completion or on right or wrong. I only grade your homework on completion. But to me, showing your work is part of the completion. If you just write down, because look, what's going to happen? You're going to look in the back of the book, right? And you're going to see the answers. And I get people do this all the time, all right? And I just see a whole bunch of answers written down because they looked in the back of the book and they just wrote down the answers. That's not going to fly. I got to see that you showed your work, okay? I want to see that you tried to do it. You actually physically did the work here, all right? So anyway, enough of that. Let's go on. Let's do another one. Well, the other two, I'm going to save some time. The other two examples, B and C, are just about identical to what we just did. So let's jump to example 9. Same kind of thing, a little bit more involved, not a whole lot. Really, the rest of this stuff is the same kind of stuff. So this is A. When do we get out of here? 15? Is that when it is? Okay. So let's go 5 plus 3 in parentheses, and they put a dot and they put a 4. All right? So here we go. It says to evaluate. All right, evaluate this expression, I think they might say on there, but evaluate's fine. So what do we do first? We do the parentheses first. So on the other problem, I did the multiplication first. But this one, I'm actually going to do the addition first. Why do I do the addition first on this one and I didn't on the other one? Because this is in what? Parentheses. So we always do what's in the parentheses first. So let's do that. 5 plus 3 is 8. 8 times 4 is 32. And I showed my work. It wasn't much work. It wasn't much to show. I probably could have done that in my head, couldn't you? Yes, but I showed my work, and that's what I want you to do as well. Let's do another one. 4 plus 5, and that's in parentheses. Then we got, they put a dot there. They didn't really need to. They could have just put the two parentheses next to each other, and that would mean that they're being multiplied as well. Would you agree with that? But they put the dot there. That's fine. So again, what do we do first? We do the parentheses. All right, you got two parentheses, so I just work in here. What's that? 4 plus 5 is 9 times 8 minus 2 is 6. And then 9 times 6 is 54. Okay? Got to know your multiplication tables, because there will be times, maybe on the first quiz and test, I may possibly not allow you to use a calculator. So that is that's a possibility, and I'm well within my rights as a math teacher on stuff like this to say you cannot use a calculator. Now, if you had some like real long, you're not going to have this in here, but let's say you had to go 3, 6, 5, 4, 7 times 371. Now, well, actually, if I was teaching this stuff, maybe I would say you cannot use a calculator for this. But if you had something really crazy in algebra, that you needed a calculator, most of the time I would say yes, you can use a calculator. So I don't know. I have to see what's on the first quiz and first test, and I'll let you know if you can use it or not. But you need to know your multiplication tables. You need to know how to add stuff together. All right. So there could be possible times where I say you should know how to do the math on this, so no calculator. All right. I heard Mr. Jackson told a class all year they can't use a calculator at all. So, you know, but I'm not going to do that, okay? Because there's times it's just not necessary to spend a whole lot of time trying to figure out the arithmetic when I'm trying to teach you a bigger subject. You know, I'm trying to teach you the algebra part of it. I'm not really looking to see if you know what 9 times 6 is, even though you should know it. All right, enough of that. He's the new math teacher. Let's do division. Okay, that was multiplication. Let's do one with some division in it. So here's a super easy example. 2 plus 3 over 4 plus 8. All right, simple like this. Now, a lot of people might do this. A lot of people might look at it and say, oh, 2 divides into 4, so I cancel out that 2 and it goes into 4 twice. Would I do that here? No, you'd only do that if they were being multiplied. If the 2 was being multiplied by something and the 4 was being multiplied, then I could cancel stuff out. In this situation, no. Just do the top, do the bottom. That wasn't really in our PEMDAS thing, was it? But for division, work everything on the top, then you work everything on the bottom, and then if you can divide, then go ahead and divide. Does that make sense? All right, so always do the top and the bottom first, and then the very last thing that you're going to do is that division. That's really not integrated in that, please excuse my dear Aunt Sally thing. So let's do this. Let's do the top. What's the top? 2 plus 3, 5. Let's do the bottom. 4 plus 8, 12. Can you simplify that? Not in that particular one, so I just circle it and that's my answer. Let's do some more. These are fun, aren't they? You said no? Sure they are. You must have not heard my question. Part A is super easy. Don't need to do that. Let's do part B to example 10. So it's 5, and then parentheses 3 plus 4, and then plus 2. Not much more difficult, just a little tiny bit more difficult. Did you do it in your head? All right, you can do it in your head, but if all you do, if this is number 1 on your homework and you just write 37, okay, I'm going to say show your work, and I might take a point off, okay? So let's show our work. What are we going to do first here? 3 plus 4. Do what's in the parentheses first. So I'm going to keep that 5 there. That's 7, and then put the plus 2. We got one more step. Well, 2 more steps, but what's the next step? Multiply. 5 times 7 is, write it down, 35 plus 2. Now you can do what? 35 plus 2 is 37, and you're good to go. So when this is the problem that I'm giving you, if I give this to you on a quiz or a test, I don't want you just to write down the answer, because I don't know how you got that. How am I supposed to know, right? You could be looking at somebody else's paper. You could have what do you call it, photomathed it or something like that. Well, you won't be able to actually, because on a quiz or a test, did I tell you that? On a quiz or a test, I'm going to tell you to turn your phone off and put it on your desk. All right, so so hopefully that'll get rid of any phone usage on there. But I want to see the work. I want to see how you got it. Yeah, enough of that. Let's keep going. We got 2 more to do. We got plenty of time, so that's good. I was rushing to my other classes to get done this class. So we didn't really go over homework at the beginning. 2 plus 4.7. All right, so here we go. Do that one. I'll let you try that yourself. I'll give you 20 seconds. Go. Write all the steps out. Don't just do it in your head. I mean, it's good if you could do it in your head. I mean, it's not a bad thing necessarily, but I want to see. All right, 20 seconds is way up. Let's figure out what to do here. Anybody got an answer for this? 7 over what? 30? Sounds good to me. So let's do it. Let's do the top, then we'll do the bottom, right? 2 plus 5 is super easy. Let's do the bottom. Now look, I'll let you get away with a little bit of not showing your work on this one step, as long as you show me what that bottom is. So let's do that. Am I going to go 2 plus 4? Nope, I'm going to go 4 times 7, which is 28. 28 plus 2 is 30. Well, yeah. On that one, it was hard to show a whole lot of work. You could have done this, put a 28 and put a 2 plus. All right, but there you go. And that's already simplified. There's nothing to do with that. And you're good to go. One last one, part D. Now this one's a little bit longer than the others. They introduce a bracket, but the bracket means the same thing as a parentheses. So don't let that scare you off. Plus 2, parentheses, 10 plus 6. Okay. So what does that bracket mean? That's your outside thing. So you do the bracket, all right, before you add it to the 2. You see it? But inside that bracket's another parentheses. So what do you do first? What's the first thing that I do here? You do the stuff in this parentheses right here. Okay, the inner parentheses, all right? Some people might put a parentheses there instead of a bracket. It means the same exact thing. But the inside parentheses, that's what we do. So I'm just going to write 2 plus 4 plus 2 times. Let's do what's in the bracket, or in the parentheses. 10 plus 6, 16. Then close that out. I'm showing every little step on this one, okay? Everybody with me so far? Yeah, easy. Do the inner parentheses first. Now what do I do? Inside that bracket, and inside that bracket I got multiplication going on. So I got to do that before I add it to the 4, okay? What's the very last thing I'm going to do? Add the 2, right. So I keep that 2 floating down here, put the bracket here. So this is going to be 4 plus what? 32. Okay? Now in this situation, does the bracket or the parentheses really make any difference? Not really, because everything's just being added anyway. So it really doesn't matter that you do this first, does it? All right, but we'll do it. 2 plus what? 36. 2 plus 36 is 38. And there you go. That's how you do it. And that's how you show your work. Okay? Show your work when you can. Not every problem can you show your work, but when you can show it, make sure you do it. I'm actually I ordered some posters. I got to talk to Ms. Schrader about that, because I don't know if they've been ordered or not. I ordered them like in the middle of the teacher orientation thing before school started. Anyway, but she had to get approval by the administration to spend the money for it. But anyway, I got all these math posters. I've never really put math posters in my room, but I saw some of the other rooms. They had all this math stuff up. I was like, oh, all right, I don't want to be left out. So I ordered all these math posters. But one of the posters says something like bruh, you know, how you guys talk. It says, you got to show your work, or something about showing your work. I just thought that was funny. I was like, I'm always harping on showing your work all the time. I saw that poster on Amazon. I'm like, hey, I got to get that one. So anyway, that'll be kind of fun. I guess, I don't know. So there we go. Let's do your homework, or write your homework down. So we're going to call it R1B. So it's still section R1, review section 1. But this is our second homework, so we'll call it B. And it's page 16. And it's numbers 49. Now don't get scared, to 85, but I'm only having you do the odds. So that's not near as much. Page 16, like regular page 16 in the book. It's like if you look at the PDF, it's not going to be page 16 on the PDF. You know what I mean? So you're just going to have to scroll until you find it. So it's page 16 in the book. And it's 49 to 85. It's just the odds. So that means when you do a problem, how do you know if you got it right or not? Look in the back, okay? What I would do, I don't know. I was trying to think the other day. Actually, last night I was thinking about this. what's a quick, easy way that you could refer to the back? What you could do is you could go to the back, like do a screenshot or something, and then it'd be very quick to go from the book to the screenshot. You know what I mean? And then you don't have to scroll every time. That'd take forever. All right, so maybe take a screenshot of the answers, and then you could go back and forth pretty quick. But look, don't just look in the back of the book for the answers and write them down. All right, do the problem first. Then if you're not sure about it, I mean, if you're sure about it, if it's super easy and you're like, that's no problem, just go to the next one. But if it's a little bit more complicated and you doubt yourself, all right, look in the back, see what the answer is. What if you got it wrong? You just keep going. It's like, oh, well, I got it wrong. You shouldn't, all right? What should you do? What should a good student do? Go back and find out where you made your mistake, okay? So that's what you should do. Whether or not you do it or not, it's a different story, but you should look in the back and let's say you got 37 for an answer. You look in the back and said 38. And you're like, oh, what did I do wrong? Oh, that's what I did wrong, or whatever, okay? You know what I mean? So make sure that you do that. Everybody good?